Okay, so I've got a little bit of time here. Let's just take a look at day 9 of the advent of code. It's pretty interesting. They're going to give us a list of numbers like this. And then they're going to say, okay, ignore the first n, and n happens to be 25, except for this particular test case where n is 5. Ignore the first n, and then every number thereafter must be the sum of one of the previous n. So here you've got 5 here, right? These 1, 2, 3, 4, 5. That's good. So 40 must be the sum of 2 of those numbers in there, which would be 15 and 25, wouldn't it? And then 62 must now be the sum of these 5 numbers, which might be 47 and 15. And then 55 must be the sum of these n numbers, which would be 15 and 40. See, so and then what you must do is print out the first one of these numbers that does not meet that criteria. So that's the basics. And for this test, they set this n at 5, but for the main body of the data, they set the n at 25. So let us begin, shall we? Let's go to our little login here. I'm going to clear that just so that it doesn't bother us at all. And let's see, where am I? Yes, I'm in Advent of Code. So line new speckle J day. What is it, day 9? It is day 9, right? Day 9, yes, day 9. Okay. And that should make our day 9 project. Now let's go to IntelliJ. And let's get rid of day 8 here. And let's go create a new project from existing sources, which is going to be day 9. So Advent of Code, good, day 9, yes. Go to the project kludge, open it, yay. All right, yes, it's going to be day 9, yes, it's going to be that. Let's pick 1.8 for our Java version, next. And day 9, fine. Okay, dokie. And here it is here. It went up to my upper screen, but I'll bring it down low to you. Lovely, lovely. Okay. Now, good. Here's the spec. Here's the source. That's lovely. Let's add our Lineagen configuration here, which is going to be named auto, and we're going to give it arguments spec-a. That's how you do an auto test. All right, and when I run this, JVM startup time, there we go. All worked lovely, good. So now we're going to load up the core here, and then do our window to get the editor tabs and split it vertically. Let's slide it over, and then let's load the spec. And so the spec is going to be on the left, and the code's going to be on the right. Fine. Let's delete the spec and the code. That is automatically given to us. And why don't we put in the acceptance test? Just for grins, let's put the acceptance test in right now. Describe the acceptance test. Okay, so the input data is going to be, heavens, let's go get the input data for the acceptance test. And that's going to be this list of numbers right here. And we will put it in here. Now, yeah, I'm putting it in string form. It's convenient, I suppose. So let's just leave it that way for the moment. And after that, we should say it passes first acceptance test. Problem 1. Acceptance test. All right. And that should be rather straightforward. It should equals, and the acceptance value here is 127. So apparently it is this 127 here that is not the sum of these 5 numbers here. There is no way to get 127 by adding those 5 numbers up. At least that's what it says here. Almost every number is the sum of the only number that does not follow is 127. What they want, however, is the first number that does not add up to 127. So we can't count on the fact that the one that doesn't add up to the sum is unique. All right, so we're going to go back. It should be 127. And find what would we call this? Find error. Let's call it error. Find error. Find some error. Okay. Of the input. Good. So we're going to find the sum error of the input, and the input is going to be the strings. That's lovely. Okay. Well, we can write, find some error. And for the moment, we're going to return null. Nil, whatever you call that. And gee whiz, yes, okay, expected 127 and got nil. All right, well, we're going to have to parse this incoming string. That should be pretty straightforward. I don't even think I'm going to write a test for that. So the next thing would be to figure out the combinations. So what we're going to have to do is walk through this list, starting at position n plus 1, or actually position n because it starts at 0, and look back, get a substring or a subsequence of the previous n, then do the combinations of n things taken 2 at a time, sum them to make sure that to get their sums, and then make sure that our number is in the list. That's kind of it. So let's see if we can do that. Oh, and find some error input. We need the n in here, don't we? So let's do this. That's going to be 5. Let's make this n. All right, good. And I don't think we changed anything. No. Okay. So we're going to want to parse that input. Let's do that. So that's going to be what? Closure dot string slash split lines looks like. And do that. Fine. Good. Yes. Lovely. And put that there. That's nice too. Looks like something went wrong here. So that goes to there. Oh, yes, right. That bracket should be out there. Okay, that line is too long. Let's do this. Okay, and let's do that. Okay, let's print the input and see what the input comes back at. Yep, bunch of strings. Okay, well, we're gonna say let's map that. Map by integer slash parse int. Yeah, I don't need to put the paren there. So we're going to map that integer parse int. Okay, close that down and run it. And oh heavens. What did I do wrong here? Integer parse int. I think that is the right spelling. But it can't find it. Okay, so let's do this. Couldn't find it in that context. I'm not exactly sure why. Okay, and what did we get? We got the list of numbers. And notice it's a list and not a vector. So let's change this to a map v so that we can keep it as a vector, because you remember about that get thing, right? That would be a pain to lose that. So, okay. That's going to be our input. Good. Fine. Now, let's put a blank line there. Okay. Now, describe. I want to get the tools here, the things that I'm going to need. And what I'm going to need here? Well, I'm going to need to get the subsequence. So, tools. Okay, fine. It should find subsequence. All right. I believe what I'm going to need here is the subsequence starting at n and for some number. So, first of all, is there a function that does that? Let me look that up. There is. It's called Subvect. So I don't think I need to write one for this. Should find so let's find combinations. So we're going to find the combinations of the subsequence. Okay. Should equal. Well, let's see. How is this going to work? I don't know. So let's do this. Called get combinations of starting at position 2 for a length of 5 in 1, 2, 3, 4, 5, 6, 7. So starting at position 2 would be here, for a length of 5 would be there. Let's not make it a length of 5 because that's a lot. Let's make it a length of 3. All right, so starting at position 2 for a length of 3. What are the combinations? Well, the combinations are going to be 3 and 4, 3 and 5. Okay, Bob, type this correctly. Let's do it this way. 3 and 5. 3 and 4, 3 and 5, and we're only doing it for 3, right? So 4 and 5. Those are the only combinations. So that's what I'm expecting for get combinations. All right, let's write get combinations. Of, okay, what is the, okay, start, n, and list. Don't call it list, call it numbers. The reason we don't call it list is because list is kind of a keyword. It's actually not a keyword, but it's the name of a common function. Okay, get combinations. Well, first of all, we want to get the subvect. So let subsequence, call it sub, be the subvec of numbers starting here and ending there. I believe that's just how you do that. And then we want to get the combinations. And that we can get with the combinatorics, right? So let me just look that up quickly. So what we want to do here is require the combinatorics. Okay, fine. And what we're going to say now is combo slash combinations. I think it's called combinations, yes, of the subvector and n. Okay, did I do this correctly? Because, no, and 2. Yeah. The subvector and 2. Good, yes, all right. Now, it seems to not know where this is, so I may have to go get it. So let's go to the closure. Oh, heavens, yes. Let's go to the project kludge file. And I'm going to have to go get it because I don't have it loaded. And let's see, we want... All right, we got to add to the dependencies that, right? There's the math combinatorics. Oh, lovely. Yes, okay. Import the changes down here. Let's see if that makes it work. And go back here, and ooh, looks like it finds it now. That's lovely. And let's run it and see what happens. Heavens. Okay, could not locate. Yeah, okay. So let's do this. Let's rerun everything and see if it gets it that way. Ah, yes, it did. Okay. 3, 4, 3, 5, 4, 5, and we got nil. Let's print that subvect just to make sure that we did that correctly. Println sub, because that might be the problem. Right, okay, and let's do that. Okay, and we will take a look at what the subvector was. Well, yeah, that's not a good idea, right? So apparently it's subvec start, and n was 3, but maybe that's start plus n. So let's do this. Let's see what that gives us. And now the subsequence should be, ooh, looks like that worked. The subsequence was 3, 4, 5, and we did find the combinations. And it was interesting that, you know, they did actually come out in that order. Okay, well, that's lovely. So that means we can get rid of our dumb little print statement, and we can make sure that we get the combinations. Well, okay, we should now be able to get the sums. So getting the sums ought to be dirt simple, right? Let's do this. Let's go get the it here. There's that it. So, okay. Let's say it should find sums of combinations. Okay, well, the sums of the combinations for 5. We'll use the same data here. Okay, so the sums should equal, looks like 7, 8, and 9. Well, isn't that interesting? Okay, so this would be get sums of get combinations 2 and 3 of that list right there. It's a reasonable way to do this. Okay, get sums of get Now this is going to be a dirt simple thing. I don't think this is going to be difficult at all. Define get sums of the combinations, right? And this is going to be map V. I don't actually think we need a map V here now because all we're going to do with this is filter it. Okay, what is the, what are we going to do here? Well, let's see if we can just type it up here. Reduce plus percent. Because, we got a list coming in. Might as well just, combinations. Yep, that's it. I believe that's just going to function. Ah, yes, good. That did work. Lovely. Okay, so the next thing we want to do is just filter that. And I believe I'm ready to solve this problem. Let's see. Well, let's go to our acceptance test. Well, let's write the solve function. Let's write the solve function. Okay. Describe the solvers. All right. It should solve number 1. This is problem number 1. Day 9, problem 1. Okay. let's be pedantic. Okay. Let's do a simple one. So we'll just do that one right there. Right? Are any of these out of bounds? Well, if we say that n is 2, then 3 is 2 plus 1, 4 is 3 plus 1, 5 is not a sum. So 5 would be the first one. Okay. Okay, so let's see. Should equal 5 of solve 1. That's the first problem. And we're going to say this list. Okay, that's our list. And we're going to say 2. So the first thing we're going to look at is that one. And, is 3. And that'll be 1 plus 2. And then 4 will be 1 plus... No, 4 won't be. 4 will be wrong, right? Because 2 and 3 don't add up to 4. So, yeah, that's going to be the first one. So that's going to be 4. Wonder why I got confused by that. Okay. So that's a simple way to do the solver. So let's write solve 1. And that's going to be n and numbers. Okay. Well, the first thing we need to do is, fine. We've got let's assume that we have the numbers, right? So we're going to say let the sums be no. Okay. What I need to do is say let the indices let the indices be the range from n, right? So 0, 1, and then 2, yep, to the number of numbers, right? So the range is going to start, and I want to look at every number after that. So count numbers. Yes, okay. Now let's print that range, because indices. I want to see what those indices are. And didn't like something. Unable to resolve symbol count numbers. Count numbers. Yes, Bob. All right. Yes, okay, so it's going to be 2, 3, 4, 5, and 6. Well, is that right? So 2, 3, 4, 5, and 6. Yes, that is right. Okay, so we got the right range. Those are the indices. All right. Now, what are we going to do? For index of indices, so we're going to loop through this thing using the indices. Yes. All right. I have a funny feeling. Well, okay, let's just keep going. Let's just keep going. Let all the possible sums this is all the possible sums at this index. So we're going to say get sums of the get combinations of index n numbers. Okay, that's going to be the list of sums. Now that's really interesting. And because that's interesting, I just want to see it. So let's print those sums right there. And we should see a bunch of sums somewhere. Well, I don't see any sums somewhere. Why don't we see any sums somewhere? Did I not call solve one? I did call solve one. Do I have solvers running? Yes. Okay. Should solve date? Yes. Okay, so definitely ran it. But, let's see. Expected for got 2, 3, 4, 5, and 6. That was the indices here. What if I were to print sums there? What would happen now? It didn't print the sums. Ooh, unable to... Yeah, okay, fine. Thank you for that. Yes, okay, so I probably want to return sums there. Heavens, no, I can't do that because that wouldn't be a good idea. And it won't print them, oddly, so which means that it's like it didn't get in here. Got an index out of bound exception. That's interesting. Oh, good. Look at that. We got some sums. 7, 9, 11, and 13. Now, I don't know why they came out like that, but let's see. What is my number? Oh, yeah, it's 2, right? So 7, 9, 11, and 13. Is that right? Well, 7, 9, 11, and 13. Yes, that is correct. And that's the only one that worked. And then we got an index out of bounds exception. And why did we get an index out of bounds exception? Well, probably because it tried to go another step over, right? So we're doing index 2 here, the very first index, and then it tried to do index 3. And when we get the combinations of index 3, it should have worked okay. So, but we got an index out of bounds. Now where? At Corkledge 8. So there's something in the subvect that didn't work right. Let's see, what's my n? My n is going to be 2. So it should have gone ahead and gotten... Yes, I'm doing this wrong, aren't I? I want to start... at n. Right, that is the index of the first number I want to begin at. However, the combination should begin at index minus n. There. Okay, so this should be minus index n. Aha, he said. And let's just see if we can make this look better. Yeah, okay. Why is that not lining up quite the way I like it? Well, I guess it's okay. All right, so now if we run that, okay, we didn't get the index out of bounds exception. We did get some interesting numbers here. So we got 3, 5, and 7. So, 3, 5, and 7. And then the next thing we got was 9 and 11. Those were then that should have been the sums of those. I'm having trouble with this, right? So this is the first index, right? First index was here. That's the first index right there. The second index was here, and our n is 2. So the sums that we're interested in would have only been 2. Right, okay, I think I'm seeing it. Right, and then the next one, so that would have been 5, and then the next one here would have been 7, and the next one would have been 9, and the next one would have been 11, and do any of them equal? And the answer, of course, is no, none of them equal. So, well, actually, the first one does. First one equals. The second one does not. The third one does not. The fourth one does not. The fifth one does not. But the first one does. First one equals. So the 4 should be the first one that does not. Good. Okay. So that means we have the sums. Okay, we got the sums. And that does seem to be correct. Now, did the number match the sums? Okay, so now what we say is those are all the sums for this index. Do any in this index match the index? So let's get the index. The number is going to be the nth numbers index. Right? Okay, so we're going to get the index number. That's going to be our number. And then we're going to say matches. I remember contains doesn't quite work right. Remember that one? So we're going to say matches is the filter of equals number percent of sums. So the matches will be all of the numbers that equal the number, right? Okay. And let's do this. Let's say match. Was there a match? And the answer to that is going to be empty question mark matches. And that'll be a not. Which, by the way, I think that's sum. Not empty and sum are the same, I think, but I'll just leave it as not empty at the moment. So, is there a match? Okay, now. Now what? Well, okay. If match if it's a match, then it's the number or nil. Well, that's damned interesting, isn't it? Now, what happens when I run this? First of all, what the heck is it returning? Okay, let requires an even number of forms. Oh yeah, because that's like outside of that one. So I want to close that bracket and do that. Yeah. Okay, all right, now run that. Okay, and okay. Got 3. Nil. Aha. So 3 was the match. I want the first unmatch. So I don't want that not in there. I want the first of the ones that do not match. No match. Right? If no match, number nil. Okay, now let's do this. Oh, look. The first one that's not nil is a 4. So now what I want to return... okay. Remove nil from that. No, not there. Okay, so okay, so the number that we want is this 4, and the way we're going to get that is to filter out the nils and then get the first element, right? So, okay, I think we're going to do this. It's going to be the first of the filter, or remove nil question mark of everything else. So take those 2 parentheses right there and put them there. And let's see what happens here. Ooh, look at that. We solved the 9-day problem. Okay, all right. So now we want to try the acceptance test. So let's do the acceptance test here and find some error. So find some error. Okay, we're going to have to take that and move it down here. All right. Look at that mess of parentheses there. Here, let's fix that mess with parentheses because that's terrible. We're going to have to do some refactoring here because this is a mess. But okay, all right. Like this. This is terrible. Look at that. Okay, find some error. N input. What is input? Input is going to be... let's see. It is this... Ooh, it's already been map v'd, right? Has it? No, it has not. It is this. Yes, it has. Input has been map v'd. It has been done. So that's just going to be solve 1, 5 input. I think that's it. And I wonder what that's going to do. Oh, heavens, that worked. Okay, well, what that means is that the final solver I should be able to write. So, okay. So that's, let's see, let's describe the solve. Okay, so it solves the first problem. All right, and that's going to be let input be the slurp of input. Good, Bob, that's right. Okay. And, yeah, don't close that brace there, Bob. That's the wrong place to close that brace. That's right. That's the better place to close that brace. Okay, now, input is going to be the closure dot string / split lines of input. Yes, I know I could use a threading operator, but it's just easier to do it at this point. Input is equal to the map v of integer / parse int percent of input. Okay, and then the result is going to be find some error yeah, so that was supposed to be n there, wasn't it? N and find some error up here was 5. Yes, okay. Find some error 25 of input. Yes, okay. I believe that's everything. So, should equals. Okay, that's going to be our test, and we run this, and what does it say? Unable to resolve v in this context. That's because I'm stupid. That should be an n. All right, run it. Okay, what did we get this time? Input no such file or directory. Oh, that's because I never got the input file. I never got the input file. Okay, let's go get it. There's the input file. Okay, great. We're going to copy that. Thank you for that. Good. Okay, now go here. And let's put the input file in here. Good. All right, there it is. All right. And oh, look at those numbers. All right. That's pretty good. Those are the numbers there. So we're going to look at that. And now we're going to run that. And what did we get? Let's just hit the run button. Okay, do. What do we get now? Number format exception for input string to. Okay, so that's a number format exception on core spec 37. 37 core spec 37. So I obviously did this wrong. So we're going to slurp it in. We're going to split the lines. Then we're going to parse int the lines. Isn't that what I did up here? All right, split the lines, parse int the lines. Yeah, should have worked okay. So let's take a look at this. And that should print the input split by lines. And oh heavens, look at that. It did not. Oh yes. Ooh yes. Ooh. Why did it do that? That's a lot of numbers, but they look like numbers. They don't look like strings. Oh, they don't look like strings because, yeah, I'm doing a println, so they probably are strings. Here, let's take this line and move it down one. Now let's run it, and it should look identical, but it doesn't. Okay, so what was going on up here? Oh, I know what it is. These aren't ints. These are longs, aren't they? Here, how about this? Long / parse long. Yeah. Okay. Now let's try it. How about that? Yes. Okay. So we can get rid of this horrible print statement now. And we can join those lines and do another one. And okay, that's the number. Well, let's see if that's the number. Okay, dudes, is that the number? Yes, that's the right number. Okay, go to part 2. And let's go back and add that to our test so that we've got the right test going. Oh my, oh my. And now the test should just pass. Isn't that nice? Okay, so let's clean this up just a little bit because there's a lot of really ugly stuff going on here. First of all, notice that a find some error and solve one are kind of identical functions. So let's just rename this to find some error. And then we don't need solve one anymore. It has the same format. And where do we call solve one? That should be find some error. And I don't think I broke anything here. So, yep, everything still works. This just looks ugly. Let's reformat it. Ooh, that makes it look even uglier. Let's see, what should we do here? Because this is a mess, this whole thing in here. This for loop this for loop right there gives me all of the matching, the non-matching sums, right? That's what it gives me. It gives me a list of the non-matching sums. So let's take that and we'll turn that into a function. Get unmatched sums. And what do we need? Well, we better figure out what code goes in there. Okay. So let's see, we're going to need the indices. Looks like we're going to need n and numbers. That's what we're going to need. Get unmatched sum, indices, n and numbers. Okay. Almost feel like moving the indices in there, but never mind that. And here we're going to say get unmatched sums, indices, n and what's the numbers? Yeah, indices and in numbers. Okay. First of all, does that still work? Yes, it still does. Okay, fine. Now let's fix this a little bit. So first of the remove nil and get unmatched sums. That's just a little bit better. I don't think I want to do any threading on that one. This is probably good enough. I could do that in a let. We could get the unmatched sums in this let up here. So let's do that. Let's say unmatched is equal to the get unmatched sums. So let's go pull that. And then this is going to be unmatched. Does this still work? Yes, it does. Okay, so now I might be able to just join all that up. That's not too bad. That looks better. Okay. So we get the indices, and then we get the unmatched sums, and then we remove all the nils and take the first one. That makes perfect sense. Good. Now, this is a mess here. Sums is equal to get sums equals to get combinations. So once again, we can say get the combinations. So let's do this right there and make that let's make sure we've selected that properly. Okay, and we'll turn that into a variable inside this let here, and we'll call that combinations. You dog. Yeah. And it's just combinations. Combinations, not get combinations. Just combinations. All right. Okay, next. I'm tempted to join these. And then let's take this and turn that into a variable inside the let named start. Okay. So we're going to start at index minus n. That makes sense. We're going to get the combinations from start n of the numbers. That's good. We get the sums. We get the numbers. Now this looks much better. Thank you. Anything else that we can improve? This didn't turn out to be a really big program, did it? How about over here? It looks good to me. I can probably get a couple of those blank lines out of there, but other than that, I think that all looks fine. A little bit long here, unfortunately. I'm not too worried about that, frankly. Okay, I think that's enough of a cleanup. Everything's still run okay. Yes, it does. All right, guys, thanks for watching. I leave the second part of this exercise for you.